Dear students, we are now commencing with a new lecture series on the topic graph theory. Here we have the first lecture where we will be learning what is a graph and how to represent a graph, loops and multiple lines, adjacency and incidence relations, and degree. We will be not doing the exact definitions of these concepts since it is available in the textbook already. We will try to understand what is a graph and how to represent a graph first. So first here we have what is a graph. So if you see, a graph consists of vertices and edges. So a graph consists of vertices and edges. We will see an example. So if you see, here we have a graph where these are known as vertices. So they are known as vertices of this graph. And you could see these lines, and these lines are known as edges of a graph. Vertices can also be called as points or as nodes, and the edges can also be called as lines, arcs, or they can also be called as links because they link between two vertices. So if you see, there is a link between these two vertices, and that link is represented by joining and those two vertices with the help of an edge. So these are the edges and these are the vertices. So this is a very simple example of a graph. So a graph consists of vertices and edges. We shall now see how to represent a graph. See, a graph has vertices and edges. So it is represented as capital G of V comma E, and the representations differ as per the textbooks that we follow. In general, since it has vertices and edges, it is represented as an ordered pair, and the graph G is represented as G of vertices and edges, that is G of V comma E, because it is a combination of vertices and edges. It can also be represented as G equal to V comma E. Then, and what is this V? V stands for the set of vertices, which can also be represented as V of G, because vertices of G. And this is a vertex set. Okay, so it is known as vertex set of the graph G. And then the set of edges can be represented as capital E, which can also be represented as E of G, which implies it is the edge set of the graph G. So the set of vertices of G is represented as V of G. So for example, here we have a graph and I'm going to name these vertices. For example, this is going to be V1, this is V2, V3 and V4. So now how many vertices are there in this graph? There are 4 vertices. So they form a set. So how this set is formed? V1, V2, V3 and V4. So those vertices are put in the form of set and it is represented as capital V of G, which is known as the vertex set of G. And what about the edges? There are 3 edges. So this is an edge which joins V1 and V2. I'm going to represent it as E1, edge 1. This is edge 2 and this is edge 3. And this is purely my own representations, and it can differ as per the textbook also. So here E1, E2 and E3 are 3 edges. Now we will form a set. So it will be E1, comma E2, comma E3. So these are the edges, and and the set is known as edge set of G, represented as capital E of G. Now what is this V1 from this set? It is a vertex of the graph G. So for example, if you take V1, it is known as vertex. And I already told you it can also be called as points. So since I am taking only one, it is a point. Or it also has the name node. So these are the different way of mentioning a vertex. And what about the edge? If I consider one of the edge, E1 for example, it is an edge. and it can also be called as a line or an arc. And since it links, we can call it as a link also. So these are the different way of calling the vertices and edges of a graph. So similarly, V2 is a vertex, V3 is a vertex, and V4 is also a vertex, and E2 is an edge, and E3 is also an edge of this graph, and together they form a graph. The next representation that we will be learning is modulus of V, which will give us the number of vertices of this graph. So, that is also known as the cardinality of the vertex set. So, cardinality of the vertex set. So, if you see where is the vertex set we have here. How many vertices are there? 1, 2, 3, 4. There are 4 vertices. So, the number of vertices for this graph G is 4. So, therefore, modulus of V is equal to 4. That is the number of vertices. And that gives us the cardinality of the vertex set. Now, in a similar way, we can say modulus of E will represent what? Number of edges. So, the cardinality of the edge set. And for this given graph, how many edges are there? 1, 2, and 3. There are 3 edges. So, what will be modulus of E? That is the cardinality of the edge set will be equal to 3, since the number of edges is 3. So, these are the representations for number of vertices and number of edges of a graph G. So, with this basic knowledge, we will further learn what are loops and multiple lines in a graph. So, now here we have a loop. So, what is a loop? A line joining a point to itself is called a loop. And what are multiple lines? So, lines joining the same points are called multiple lines. We will learn this with the help of an example. For example, if you see, for example, if we take some 3 points like this, and there are edges between them. So, these are the edges. Now, we know that this is a vertex. So, when a line joining a point to itself, it is called a loop. So, loop will be like this. A line, it is a line, okay, joining a point to itself. So, if we started from here and we came back to the same point. So, such a line is known as a loop. And what are these multiple lines? Now, for example, these 2 vertices we already have an edge between these 2 vertices. Now, if there are some more edges like this, they are known as multiple lines. So, it has more than one edge, and that edge connects the same 2 points. So, lines joining the same points are called multiple lines. So, this is also an example of multiple lines. Okay, we will learn these 2 concepts more further, that is with another one more example. So here we have another example. Now we will see what are the vertices. What are the vertices of this graph? The vertex set V of G will be equal to, if you see, V1, V2, V3 and V4. So there are 4 vertices. So V1, V2, V3, V4. So since there are 4 vertices, modulus of V will be equal to 4. And tell me the edge set of this graph. So how many edges are there? E1, E2, E3, E4, E5 and E6. So E2, E3 and then E4, E5, E6. So there are 6 edges. So modulus of E will be equal to 6. So these are the cardinalities of the vertex set and the edge set. And where is the loop for this graph? So E4 is the loop. So you can see that E4 is the loop we have. And what about the multiple lines? So the multiple lines are, for these 2 vertices, there are 2 edges joining these 2 vertices, E2 and E5. So they are the, E2 and E5. So these are the multiple edges, and it can also be called as multiple lines. So I hope you would have understood what is a loop and what are multiple lines. So next we are going to learn about adjacent vertices. So what are adjacent vertices? Now if in a graph you have vertices u and v, when are they said to be adjacent to one another? So any two vertices u and v of a graph G are called adjacent vertices in G if there exists an edge in G joining U and V. That is, so if we have two vertices and if a line join these two vertices and if those two vertices are U and V and if there is an edge between these two vertices, then these 2 points, that is the vertex u and the vertex v, are said to be adjacent to one another. So they are adjacent vertices. Now if suppose we have another point where we have the line between v and w, for example. Now v and w are adjacent vertices, but there is no edge between u and w. So there is no edge actually. So these two are non-adjacent vertices because there is not an edge between these two vertices. Whereas there is an edge between v and w, which implies that v and w are adjacent to one another. And in a similar way, u and v are also adjacent to one another. So this is the concept of adjacent vertices. Now here I am taking a very simple example. There are 4 vertices in this graph and 3 edges. Now can you tell me what are the vertices that are adjacent to one another? See, if you see here, u and v have an edge between them. So u and v are adjacent to one another. Similarly, there is an edge between V and W. So here U and V had an edge. V and W also have an edge. So even they are adjacent. And similarly, X and W have an edge between them. So X and W. So all these three are adjacent to one another. All these three pair. Because there is an edge between U and V, there is an edge between V and W, and edge between W and X. So U and V are adjacent, V and W are adjacent, and X and W are adjacent. Can you tell me which are the vertices which are non-adjacent to one another? If you see, U and W are non-adjacent to one another because they do not have a direct edge between them. So if there is a straight line joining these two vertices, then they would have been adjacent to one another. But since we don't have, U and V are non-adjacent, U and W are non-adjacent to one another. In a similar way, we can also say U and X are non-adjacent to one another. So U and X, U and W. And then we can also say that that is U and W, U and X. Similarly, V and X are non-adjacent to one another. So V and X. So these pairs are non-adjacent to one another. So this is the concept of adjacent vertices. Next, we will see what is an incidence relation. For example, if you have two vertices in a graph and it is connected by an edge. So if suppose these vertices are represented as u and v and the edge is represented as e. Now these 2 points are connected by the edge e. Now what is this incidence relation? Always remember, the incidence relation will be a relation between vertex and the edge. So the relation between vertex and edge, where if you see here, this edge E is incident with U, which means there is an edge emanating from U. Also it is incident with V. So U and E are incident to one another. So the pair is formed in this manner. So U and V are incident with one another. Similarly, V, the vertex V and the edge E are incident to one another, the same. So, when there is an edge emanating from a point U, then the edge and the point are said to be incident to one another. I will explain this with one more example. So let me consider this very simple example which we saw in our previous case. Now here I am having vertices u, v, w, x and edges e1, e2, e3. Now can you tell me the incidence relation in this matrix? Now this vertex u is incident with which edge? Only one edge. So u and e1 are incident to one another. So this is the pair. What about v? V is incident with two edges, E1 and E2, because two edges are emanating from this point. So if you see, V and E1 is a pair of incident, that is this edge E1 is incident with this vertex V, and also V is incident with E2. So this is how the incidence relation is formed. What about W? W is incident with two edges, E2 and E3. So W E1 we have, and W E3 as the pair of incidence relation between vertex W and E2. And E2, not E1, E2. These two are incident. What about X? Can you tell me about X? X is incident with only one edge, that is E3, because only one edge is emanating from that, and X is incident with E3 only. So this is how we have to form the incidence relation. The next concept that we will be learning is adjacent edges. Previously we learned about adjacent vertices. Now here we have adjacent edges. So any two edges of a graph G are said to be adjacent in G if they have a vertex in common. Or we can also say that if they are incident at the same vertex of G. For example, I am taking a vertex and three vertices, and I'm taking two edges. This is U, V, W. Now this is edge E1, this is edge E2. Now we can say that the edge E1 is adjacent to edge E2 because they share a vertex in common. So that is what the definition is. That is, we know that E1 is incident with U and E2 is also incident with U. So if they are incident at the same vertex, so E1 is incident at U and E2 is also incident at U, which means they are incident at the same vertex of G, and therefore E1 and E2 are said to be adjacent edges. So E1 is an adjacent edge to E2. Now we will consider the same example which we saw previously. Now in this graph we can say that this is edge E1, this is edge E2, and they both share a common vertex, that is they are incident at V. So since E1 is incident at V and E2 is incident at V, we say that E1 and E2 are adjacent to one another. So how is the pair formed? E1 and E2. So these two are adjacent edges. So adjacent edges. Similarly, can we see any other adjacent edges in this? Yes, of course, because E2 and E3 share a common vertex here. So there is a common vertex. So E2 and E3 are also adjacent vertices. So E2 and E3. So adjacent edges, I mean. So even they are adjacent edges. Are there any other adjacent edges in this graph? No. But we can say that similarly the other way, E1 and E3 are not adjacent to one another. So E1, E3, they are non-adjacent edges because they do not share a common vertex. They are not incident with the same vertex. So E1 and E3 are non-adjacent to one another. So this is the concept of adjacency and incidence of incidence relation of a graph G, where we saw adjacent vertices and then the incidence relation and also what are adjacent edges. Next we will learn the degree of a graph or degree of a vertex in a graph. Now here we have the concept of degree. So the degree of a vertex V in a graph G is the number of edges incident. So number of edges of G incident with V. So the number of edges of G which are incident with V, the vertex V, is said to be the degree of the vertex V. We will learn this with the help of an example. So now here we have an example. Also I would like to tell that the degree of a vertex is represented as, so it is denoted by D of V, which means degree of V, or it can also be represented as DEG of V, that is the degree of V. So any representation is fine. So now we will consider this example and see the degree of each of the vertices in this graph. So this is the graph G. Now, first of all, how many vertices are there? V1, V2, V3, V4, V5 and V6. So, there are 6 vertices. Now, for each vertices, we will find the degree. So, what about V1? So, what is the degree of V1? So, how to find it? We should check how many edges are incident with V1. Now, if you see, here there is an edge and here there is an edge which are incident to V1. So these two edges are incident with V1, and since there are two edges incident with V1, the degree of V1 is equal to what? It is 2. So this is how we have to find the degree of a vertex. Now what about V2? How many edges are incident to V2? Now if you see, there is an emanating edge from here and here and here. Are there any other edges that are incident to V2? No. So 1, 2 and 3. So 3 edges are incident to V2, and so therefore what? The degree of the vertex V2 will be equal to 3. So this is how we have to find the degree. Now what about vertex V3? So for V3, how many edges are incident? So 1, 2, 3, 4 and 5. There are 5 edges incident to V3, and say therefore the degree of V3 will be equal to 5. What about degree of V4? So if you see here, V4 has 1, 2 and 3 edges incident to it. So degree of V4 is 3. What about V5? 1, 2 and 3. There are 3 edges incident with V5, and so therefore degree of V5 is equal to 3. And what about V6? 1, 2. 2 edges are incident to V6, and therefore degree of V6 is equal to 2. So this is how we have to find the degree. And I will also tell you the minimum. There are two concepts called minimum degree of the graph G and maximum degree of the graph G. So that is for the whole graph. So how to find that? So the minimum degree of a graph G is obtained from the degree of the vertices, and whichever has the least degree, that is called as the minimum degree. Now out of all these values, what are the least value? 2. So that is the minimum degree of the graph G. So that is 2, and the minimum degree is represented as delta, small delta of G. So this is the Greek letter small delta, and so that is the representation for degree, minimum degree of a graph G. So small delta of G. And what about the maximum degree of the graph G? It is the maximum value of all these values. So for all the vertices of the graph, we found the degree. We should choose which value is maximum. So this value is the maximum value, and so therefore the maximum degree of the graph G is equal to 5. And how it is represented? The maximum degree is represented as capital delta of G. So this is small delta, which represents the minimum, and the capital delta represents maximum degree of G. So this is how we have to find the minimum degree and maximum degree of a graph G. So here are some notes to be remembered. Vertex with a loop has degree 2. So now for example, if you have a graph like this and there is a loop, so this is U and V. Now for U, already there is a loop for this. So it is of degree 2. And then there is another one edge like this. So degree of U will be equal to 3 actually, because for a loop you should count the degree as 2. So for this, the degree has to be counted as 2 edges, and this is one edge which is also incident with U. So the degree of U is 3. What about the degree of V? It is 1. Okay, and this is the degree of V is 1. If it has a degree 1, then it is known as a pendant vertex, and this edge UV is known as pendant edge. So that is also given in the note. So a vertex V of degree 0 is called an isolated point. So if there is no edge incident to it, so if you see, this is a vertex U, but there is no edge that is incident to it. So this is known as an isolated point. And a vertex of degree 1, as I told you here, is called an end point. So this is known as end point, or it can also be called as a pendant vertex. So this vertex is known as pendant vertex, and this edge is known as pendant edge. So these are few notes to be remembered. So I hope, dear students, the concepts covered in this video lecture you would have understood better. In our next lecture, we will learn the different types of graphs, and in further lectures also we will learn more theorems and properties of graph. So kindly follow the upcoming video lecture on types of graphs. Thank you.